Yeah, so hello and good day to everyone. Um, Welcome to IDEA StatiCa Summer Series webinar dedicated to concrete. And today we're going to discuss about Pier Caps with our program IDEA StatiCa Detail. I am your presenter for today. My name is Jean Valiente. I'm a product engineer for IDEA StatiCa Asia and Pacific. Um, Today's webinar, we are using the GoToWebinar platform, and you are muted by default. If you have some questions during the webinar, I have my colleague working with me in the background who will help me to try answer your questions. So please try to type your questions in the GoToWebinar application. And should we run out of time and not able to respond to your questions, we will try to answer it via email. And I may just remind everyone that the whole session of this webinar is actually recorded. So today's webinar is actually the third part of a summer series for beginners. It's called Master Your Design for Pier Caps, where in this series you will learn quickly all the basics. And of course, you can also watch a recap of all our recordings of this particular series. The recordings will be made available into our YouTube channel and or also in our support center webpage. So today's topic, let me just give you a quick overview of our agenda. I will discuss briefly about the tools used in traditional approach to design of pier caps. And then I will do the demonstrations on how to model and code check pier caps using our detailed application. We will actually make use of DXF file from AutoCAD. This will aid us in our modeling applications. And of course, we're going to combine some functions in the detailed application to complete all our reinforcement. And after that, of course, we will go through together with the interpretation of results. And later on, we'll discuss about summary of what we've done. So before I go with the demonstration, I'm going to have a quick poll. What tool do you use to design the pier caps? So I want you to select your answers, please. I want to launch the poll. Please select as many as you have used to. I'm going to leave the poll open for a few seconds. While it's still trying to collect some responses. So I can see that only 60% has voted yet. So I give another few seconds more so that all of you can try to vote for the poll. All right, I think we are good with the poll. I think I can show the results for now. I think I can see that all of you is using Strut-and-Tie method. You see, I'm going to close the poll and see from the results. Let's see here. You have 47% of all of you are actually using Strut-and-Tie method, and 11% say you use linear to DFEA, and the rest 5%, and also 37% of you guys say you don't design pier caps. Okay, that's quite reasonable results. So let me just end the poll, and I'm going to continue you with my presentation. So I'm gonna turn off my camera right now. All right. So for the traditional approach to design of this pier caps, one of the very common method to design structures with, for example, pier caps is the strut-and-tie method, the one that most of you selected. So while this has been proven over the years to be very effective in addressing ultimate limit state, this method is, as you all know, very iterative and can be very tedious to work on. And also you need to come up with multiple iterations just to get the perfect Strut-and-Tie model, which is kind of like time consuming. And to check also for serviceability criteria such as crack width, stress limitation, and deflections, you would need to address this with supplementary or complementary models and together with the code provisions. No? And then sometimes checks for serviceability is kind of like neglected, that would possibly cause this issue as well as to what you can see it from the photos, and could possibly lead to catastrophic failure like the one image on the right side. And basically we do not want this to happen. So another approach actually is the use of sophisticated programs like Abacus or ANSYS, for example. These programs are very sophisticated, that is more commonly used for research purpose, so trying to simulate reality. And due to its sophisticated, it's more commonly used. It's due for sophistication. It's actually not very common for structural engineers to use on a daily basis, as it actually requires plenty of time for modeling. And yeah, for some times, if you have some changes, revisions, for example, to the shape and geometry, some programs you may even have to start from scratch. So another alternative is actually by the use of CSFM method. No, so in this demonstration, I'm going to show how to model and code check Pier Cap using Detail 2D in IDEA StatiCa. We will model it together with a DXF file, as I mentioned earlier. So for the purpose of this demonstration, due to our limited time, we will keep it very simple and have all the information available. Of course, we are only interested into the pier caps on the top, so we do not need to check the pile caps at the bottom, but that can be another topic that we can discuss separately later on. So I have all this, the information, the concrete strength 4050, also the loadings, and we will make use of this information later on to input into our model. So I'm going to do the modeling now, and I'm going to end my slides. So let me open IDEA StatiCa Detail here. So here I'm going to make use of the design code Eurocode. There are three design codes that you can possibly use, but in this demonstration we're going to make use of Eurocodes. No? I'm going to change the concrete strength from C5060 to C4050, and I'm going to change the concrete cover to 50. So I'm going to make use of general beams or walls template here. So I'm going to create. So from here, I now have in the detail to the interface. So right now I'm going to click DXF import. So here, member, add new member. Here I have already ready my DXF files, and all I have to do is just have it open. Here I have all the informations that I wanted to. I have the geometry, the shape of the pier cap. All I just need is the shape for the concrete itself. So here I can either select the DXF origin or center of gravity. In this example, I'll just leave it as at DXF origin. I already set my units to millimeters and everything. So all I have to do now is click on outline. Once I have that, all I have to do is click on OK. Now I have my geometry available already. To add another members or another part of the structure, all I have to do is click on members again. Click again my pier cap model. Go through this one right there. This time I can select it by just holding the control button. And once again, I click on outline. Click on OK. And I have my Pier Caps model. But just take note that since we are working with DXF, so not all geometry are captured. So we need to make some modification a little bit on the structure. So that under the thickness, I'm going to change this to 2 meters. And for this member right there, I'm going to change this to 0.85. The same goes to member right there, 0.85. Now I have my geometry input correctly. Now I'm going to add in some of this about line support. I'm going to click on line supports again. And from here, I will place it under edge number 7. So you can see that you have some reference here actually that you can where you can input your support. So under you have here 1, 2, 3, 4, 5, 6, and 7, and 8. But in our case, we're going to make use of number 7. Of course, I'm going to deactivate compression only, spring support, and I'm going to activate the rotational constraint. So now I have this support added. All I have to do is provide my transferring device. So I'm going to go click on entity again, model entity, click on bearing plates. So under bearing plates, I want to place it under this member right here, which is member W2. And of course, we have a reference at the edge number 1. So I'm going to click edge number 1. And we will make the thickness of this bearing plate, or the width perhaps like 0.7. And thickness is about 150 mm. I'm going to move that into the center. So we have 0.85, so middle of that, say that's 0.425. And now I have that range. I want to make a copy of that so that I can place it somewhere under this member right here, which is about 3. So all I have to do is click on copy. And I have to just change the master to W3. Now that I have this arranged, we can now create our load case. So under this ribbon right here, all I have to do is click on load case so that I can have load case LC1 for under permanent loads. So I'm going to click on the plus new entity and load impulse, and I'm going to select self weight that I will, all those loads will be added now. Now I'm going to click once again. This time I'm going to click on point loads. So under point loads, what I can do is I apply the loads that we have shown earlier. So in this case, I have minus 4450 kilonewton, and it's being transmitted at transferring device BP1. There, that one. And the next one is I'm going to just make a copy out of this, and I'm going to change it to bearing plate number 2. But of course, we're going to change this to minus 4420. Again, I'm going to go back to this load so that I can make a copy of it and create a horizontal force out of it. Make a copy. This time I'm going to change this to minus X. And the loads that we have right here is actually 227 points minus 227.5. But I'm not going to transfer this into the bearing plate itself. So I'm going to select none. But then again, we need to transfer it into the members W2 so that it will be distributed properly. Now, in order for this, I'm going to make use of the master point number 5 right there so that I have all the interface between the Pier Cap itself. And then all I have to do is just change on the radius to say 0.20. And with this, I'm now certain that my loads will be distributed properly and it won't be a local loads only. So now that I have completed my permanent load case, I want to create my variable load case. So I can just make a copy of this load case 1 to as some kind of like a template for load case 2. So I can just make a copy. Now we are under load case 2. But for variable, we don't need the self-weight anymore. So all I have to do is just delete it. I can change this to variable loads. And of course, you need to have to change these loadings right here as well. So under variable loads, this will be minus 380, same thing. And then this one, all you have to do is change this to minus 2260. This time we already set this up, minus 124.60. Okay, so I have now my load case. In actual fact, you can actually create as many variable loads as you wanted, depending on how many load case you have. But in this specific example, we just have to create one variable load. So now I'm going to create a load combination. I'm going to create a load combinations. This will be for ultimate limit state. Now I'm going to create a copy of it, but I'm going to change it under serviceability limit state. I will leave it under characteristic, but for this case, I'm going to deactivate active for crack check. So I will leave only for deflection check. Now I'm going to copy, create load combination C3. This time, I'm going to change this to quasi-permanent. And for quasi-permanent, I'm going to deactivate deflection check, but now activate crack width check. In this case, I now be able to provide the load factors necessary for this load combinations. Under load combination C1, I'm going to change this to 1.35 for permanent, 1.5 for variable. I'm going to leave it as it is for characteristic, but for quasi-permanent load case, I'm going to change 0.3 for variable loads now. I'm going to click on OK, and I have it now complete. So basically, we are now ready to do our reinforcement right here. But before we start defining the reinforcement, I want to show you there are two tools that we can make use to help us understand the behavior of the structure. So here I'm going to click on linear analysis. This is actually a predefined tool. It will show us the conformity of the results. So here you can see the compressions and tensions fields. You can even filter this, for example, here in the compression, you can put it -1. And on the alternatively, you can also make use of topology optimization. So I'm going to run topology optimization. So just bear with me for a few seconds. It's actually take about 30 to 40 seconds to run the analysis. So with topology optimization, based on the input loads that we have just now, and based on the geometry of the structure that we laid out in our model, it gives you actually the precise alignment of I would say the compression and tension fields. No, so let us just wait for the results to come out. Give it a few seconds. Be ready, right? Okay, a few seconds more. There it is. Huh? So you will see actually that gives you the precise alignment of compression and tension fields. Here you can even change the effective volume to say 40, 60, or even 80%. Yeah. So with this visual information that we have so far, this actually gives us an idea where to effectively provide reinforcement, no? So that we could possibly optimize our reinforcement. So that's what I'm going to now shift to design tab so that we could now provide our reinforcement. What I will do is I'm going to, under the ribbon, I'm going to click once again DXF import, but this time I'm going to click on group of bars. I'm going back to my Pier Cap DXF file. And you can see here, I have my model once again. And just to let you know that there are plenty of reinforcement. Here is the first one. I'm going to just import it. This based on this. So we just click this, click on select, and the same goes to this too. I'm going to click on select over there. So depending on the thickness that you provide in your DXF file, based on that thickness, it will actually copy it based on the diameter of the reinforcement. So if, for example, you have a thickness of 20 in your DXF, your rebar will also be 20 mm in this case. So now that we have that, we can actually make use of some modification right here. This here, I'm going to change this to, I'm going to select everything by just click on shift. So that I have all this group of bars. I'm going to change this to 16. And then I have that. I'm going to go back to the 2D modes. This time, I'm going to add reinforcement on the other side by just making use of this group of bars. And I'm going this time for the pier, I'm going to change it to 25. And I'm going to change this to definition bar shape on outline of or opening on the edge. So here I'm going to apply it on the edge number six. I'm just going to select 6. And of course, we need to make some adjustment as well. So from there, I'm going to change this to 3000. And I have it. And since this is only halfway that we have, so we have to make sure that our structure is actually, our reinforcement is actually continuous all the way to the bottom. So what I'm going to do is I'm going to add this right there. So let me just shift it to 3D. I have it right there. Now I want to copy this reinforcement on the other side. I'll just have to do is copy, but I'm going to change it this and this number 8 right there, this edge number 8. Of course, because it's a mirror, you need to make some adjustment as well. I'm going to reverse this thing as well right there. Going back to 2D view. All right. Now I'm going to make a copy of this group of bars right here. And I'm going to make some changes so that I could have reinforcement right there. I'm going to change this to only 2, and concrete cover, I'm going to change this to 200, like that. But the number of bars should be 4 in this case, and the spacing should be 200 mm. Now I'm going to copy this as the same thing so that make it symmetrical. Copy, and all I have to do is just click this edge number 8 right there. Of course, since it's a mirror, we have to make some adjustment as well. Same goes here. I have that stuff. Just add one more layer, and I have that reinforcement already. So I'm going to add, I forgot to add the reinforcement at the top. So, all right, let's do that here very quickly. You can add Dixit import once again, group of bars, Pier Cap. I'm gonna make use of this. Just hold on Control and select everything, and click on Select Bars. Click on OK. Right there. So what I'm gonna do is I'm going to change this so that I will have a number of bars right there. I will change this to 6 numbers in a layer. All right. I have that reinforcement. Now we are now ready to add reinforcement for the ties. This time I'm going to click rebar assembly, group of bars, and definition bar shape. I'm going to change it to outline or opening edge. Under this one, I'm going to change it so that I could make use of edge number 3. I'll change it somewhere there. And from there, I will change it only to 4 number of layers. And here I have 14. And I'm going to space this to 175. Nope, this is only 12. Right. Okay. So I'm going to copy this reinforcement so that I could make use of this to have a reinforcement at the bottom. This is going to be a tie. I'm going to make use of edge number 7 right there. So edge number 7, this is actually a tie. I just want to show to you that for columns or beam ties, let me just go back to my presentation. For stirrups or ties can be applied only to structures modeled in beams. However, it is also possible to simulate them in other elements such as group of bars. In our example right here, we have here the stirrups, but if you make use of perfectly bonded bars, this is also equivalent to stirrups, columns or beams. So we will make use of this pictures. So here, under this column, I'm going to change this to right there. This is only right. 7. Oh, correct. This is 12, correct. Now I have that part right there. All I have to do is add some ties also on the upper part of the members. So what I'm going to do, I'm going to copy out of it. At this time, I'm going to make use of master the number 2. No, I'm going to change this reinforcement to 12. And only 2 layers in a bar. And I have 3. And here I have a spacing of 50 mm only. That's basically enough. So this group of bars, I'm going to make a copy out of it so that I could have the same thing right here. So just copy again, change the master to W3. Only have like that. So just making sure that we have everything all sorted. 12, 12. Oops, this is 12 mm. So sorry about that. Forget. Same thing here. It should be 12 as well. All right, now we have everything. So we're gonna have to add reinforcement on the transport side. So now I can copy the same reinforcement that I have from here. Perhaps this one. And I'm gonna make use of master number one once more. This time, making use of edge number 4. Edge number 4, I have here the length, so I'm gonna make some changes over there. From the start, meters, and I'm going to change this to number left 4, and this one should be 1550. Okay, now this is symmetrical. All I have to do is just copy and change it to the edge number 2. Of course, it's mirror image, so we need to do some adjustment as well to make it mirror. I want to add it to that, something at the center. Okay, so we have this reinforcement modeling ready. So right now, we are now ready to calculate. So if I hit on calculate, so I'll calculate our model, no? So, but to save us a little bit of time, I actually prepared a results for us right there. So here, this is my results. So you can see that under summary, we have under all ultimate limit state, we all have a successful verification, but in SLS, we have some overutilizations for stress limitation and also for crack width. So let's review first the results. Under strength, you can see here the principal stresses in concrete and also for the limitations. We have here 99.5%. If I go to reinforcement tab, I can also see how the reinforcement is being utilized. And from this view, I can already see that we have an under optimized. We're not optimizing the reinforcement at the pier side. So later on, we can make some adjustment right here. So just by this view alone, we can already make use of this, that, okay, we can actually save some material. So if I go to anchorage, the same thing. You have the view for anchorage. Now, if I go to stress limitation, you have all this stress peak right at this very corner right here. Now, we can address this later on, but before we address this, I want to move forward to crack width first, before I address that stress limitation. So under this crack width check, we have this image right here where it shows where exactly the cracks will appear, and I can see that we can make use of slightly maybe more dense reinforcement, perhaps make some adjustment so that we could make it work with our crack width checks. So what I'm going to do, I'm going to go back to design tool. I'm going to change that specific bar that would influence our crack width check. So here we have a spacing of 175. So I'm going to change this to 150. Because I'm going to change this to 14 in this case. Yep, that's good. And we also see that at the bottom, this reinforcement right here is actually not optimized. So what I can make use of is change this reinforcement to a much smaller in diameter. So I could just show that instead of using 25 diameter, I can just make use of 20 diameter to save on materials. And now now that we have made these changes, I can now run the model once again. So if I hit on calculate, it will give us the results now. So, but to make to give us save us some time right there, I also prepared results for you guys so that we have there. So you can see that under the crack width, it's now we now make it pass. We were able to make it pass based on the adjustment that we made. And if I go to stress limitations, so we still have this stress peak appearing right here. Now, what usually happen here, we just make this is actually some sort of like a stress singularities. So let me just share my screen once more. My slides, let me just look at that. So here, when we can stress peak be neglected, no, it's a stress. So first we have to identify whether this is a singularity or a stress concentration. No? Actually, a stress singularity is a point of the mesh where stress does not converge to a specific value. No? So no matter how you refine the mesh, it will always keep on increasing. So even if you make a finer mesh, it won't even help. On the other hand, for stress concentration, although it behaves the same thing as stress singularity, but it's actually converged towards infinite value, no? Or finite value, I mean, not infinite. So in reality, actually there's no perfect corners, no? So even if when you design the corners to be very sharp in actual fact during construction or once it is fabricated or manufactured, there will always be fillet on all those corners. So one thing that we could make to do here is actually refine these edges. However, we have these functions in IDEA StatiCa that if we found out that okay, this is actually stress peak singularity that doesn't affect the overall stability of the structure, we have this limited check function. It's actually according to Eurocode standards. So let me just share my screen my slides once again. So with that, we actually have some sharp edge. Those stress peaks would still be occurring. And if you try to refine the edges, the results will be actually will make it more refined, and you will have a much better results for stresses in this case. The other options that we have for tools that we have in IDEA StatiCa is actually make use of limited function check. Now we're in with this one, can make use of and activate these functions as long as you know that this stress peaks actually does not affect or influence the overall stability of the structure. So going back to my slides, I mean my sign right here. Now I can, now that we have to make it pass, I actually can go now to the report. And from the report, I actually can just say, select whether a detailed or brief report. In this example, we can customize this and I can say, okay, I want to check this one. And I can click on generate report. So once the report is generated, you can see all the calculations that has been generated by our software is all under this report. No? And you can see that since we activate those limited function check, there is some notifications right here. so that when you submit it to checking engineers or engineers of records, they are aware that, okay, this function is activated and that is according to the standards. So here from this report, you can see some colorful visualizations where you can review as well whether you have made it correctly, and of course check some values. Okay, here if I go back, here is the non-conformities that we are talking about. So you don't have to worry actually about this, because it will also be included into the report. And of course, in the report, you will see also bill of materials. All right, so that's basically for the Pier Cap. Let me go back to my slides and just give you a little bit of summary. So what is actually the benefits of using CSFM method in IDEA StatiCa? So first, of course, time saving. When you are using a common design approach, like for example, Strut-and-Tie method, it would take roughly about or even 4 hours or more. And then with CSFM method, you can see that with our how we did it, we made it for like half an hour or maybe even less. Second, Second is actually material optimization. So thanks to CSFM, you not only have the possibility to check whether your design is satisfactory, verified, but you can also see through those colorful visualization where you can effectively adjust your reinforcement, or maybe just to optimize and cut back on reinforcement to reduce some materials. And lastly, of course, safety due to code compliance. This includes serviceability checks such as crack widths, stress limitations, as well as deforming. All right, so what's next? Okay, so once again, I would like to invite you to join me into the next series of webinar, which is entitled Pre-Stressed Beam with Opening, which will be on 20th of August. And also, my colleague will be presenting the final installment of the series entitled Precast and Infrastructure Beam, which will be on September 11th. So, and also after the webinar, we will have a short survey. So please try to fill in the survey. It will actually help us improve our webinar. And of course, you can also suggest in that survey some topics for future webinars. The recording will be available in our support center webpage, and it will also be uploaded to our YouTube channel. And if you're interested into our program, you may also download the trial version to test our application. And also, if you're looking for some information regarding the usage of our product, please visit our support and learning page. Here you can see some knowledge-based articles, tutorials, webinars, and more. So yeah, so basically that's it for now on my side. Thanks once again for joining me on this webinar, and I hope to see you again in the next one. So bye-bye.